Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Aribhat College, University of Delhi. So as you all are aware that presently we are going through our series of Introduction to Programming using C++. Today's topic is exception handling. In the starting, when we have just begin with C++, that I have already told you that your C++ is actually, or C++ can be described as C plus some object oriented paradigm features. So basically we can say that C is actually a subset of C++, and coming to the extra things or extra points which are associated with only C++, not with C. One of them is exception handling. So I can say that one of the advantages of C++ over C is exception handling, because exception handling is not available in C or not available with C, but it is available with C++. So now let us try to understand that what is actually an exception. So exceptions are basically, we can say, errors or anomalies or abnormal conditions. So whenever I am talking about the errors, or whenever I am uttering the word error, the first thing which comes into my mind is kind of a normal compile time error, which is actually handled by the compiler, but exceptions are not compile time error. Let me make it very clear that exceptions are basically not the compile time errors, but runtime anomalies or some abnormal conditions that a program may encounter, or that a program can encounter during its execution. So what do I mean by this? So for example, I am saying that there is an abnormal condition, or there is an kind of problem, or there is an anomaly which is not a compile time error, and the program is compiled we can say correctly, because in compile time your compiler is looking for syntax error. There is no syntax error in a program, but there are some errors which are going to give some problem at the time of execution, at the time of running the program. For example, let's say I am writing C is equals to A by B. That is perfectly fine. C is equals to A divided by B, and whenever I am taking the value of A and B dynamically, let's say I am saying A is equals to 5 and B is equals to 0. So here it is going to be C is equals to 5 divided by 0. Then that means whenever I am trying to say divided by 0, actually whenever we do normal mathematics on pen and paper, it comes to infinity, but we don't have any kind of such provision to encode or to represent infinity here. So division by 0 is some such error which may occur at runtime, and these runtime anomalies are known as exception. And whenever I am saying that we are going to learn, or we are going to study exception handling today, so basically I mean that how are we going to handle these exceptions which may encounter during the runtime. So it's a kind of foreseeing the situation, foreseeing the anomalies which may encounter at runtime, and giving different provisions in order to handle those anomalies. So that procedure, that whole process is known as exception handling. So basically I can say, whenever I am executing a C++ code, please remember here I am saying whenever I am executing, I am not talking about in exception handling, I am nowhere talking about the compile time thing. While executing a C++ code, there can be different errors. This could be kind of some errors which are made by the programmers, or errors due to the wrong input, or some other unforeseeable things which I have example of which I have just given, that the value of B is 0. So value of B is 0, it's, we can say, it's a kind of wrong input. Whenever such an normally a compile time error occurs. C++ takes it at the compile time, but whenever these type of errors occur, C++ will normally stop and generate an error message. The technical term for this is C++ is throwing an exception or throwing an error. In order to make it, in order to keep it differentiated from error, we will not say it as it is throwing an error. We will say C++ or the program of C++ is throwing an exception. So whenever there is an unforeseeable thing, any wrong input or any other error because of the programmer's mistake, it is not a syntax error. I am repeating it again. Let's not mix it with the syntax error. In these type of situations, an error occurs. C++ is going to stop and generate an error message, and the technical term for this whole process is, we can say that C++ is throwing an exception. Now, if I am talking about the exceptions, whenever I am talking about errors, we will say that there is a compile time error and there is a runtime error. Similarly, talking about exceptions, we may have two types of exceptions. One is a synchronous exception, another one is an asynchronous exception. Synchronous exceptions are those which can be handled by a programmer using the mechanism of exception handling. But asynchronous exceptions are those which are beyond the control of program or which are beyond the control of programmers, like disk failure. So disk failure is some such thing. That is also a kind of, we can say, exception, a runtime error. But disk failure is something which is kind of very unpredictable, and we cannot have any such code which is going to handle disk failure within our program. So within our program, we fix no mechanism of handling the disk failure. But if we are suspicious of having a denominator in operation of division as 0, which is going to trigger a condition of division by 0, we are we can foresee that, and we are supposed to handle that within our program. So those kind of exceptions are known as synchronous, which can be handled by the program, and those kinds of exceptions which cannot be handled by the program, they are beyond programs or programmers' control. Those exceptions are known as asynchronous exceptions. So basically two types of exceptions. One is synchronous, which can be handled by programmer, asynchronous, which cannot be handled by a program's control. Now, whenever I am talking about the term exception handling, we have three keywords which are specialized for the purpose of exception handling. These keywords are: 1, try; second, catch; and third one is throw. So try, catch, and throw. So let us try to explore these terms one by one. So try, the first term, represents a block of code that can throw an exception, that may throw an exception. That is, that block of code is actually a block which can be tried. It may throw the exception or it may not throw the exception. So we are in order to understand that, we can say we are giving it a try. So that kind of code will be enclosed inside a try block. Then there comes the second term, which is known as catch. Catch represents a block of code that is executed when a particular exception is thrown. Let's say there is an exception or there is an error which is encountered. Now what? Your machine has to have a clean exit for the whole program. So in order to provide that clean exit, that block of code which will be executed when an exception is thrown. Exception is thrown means when that kind of a particular error occurs which is to be handled. So catch is going to represent a block of code, and that block of code will be executed in order to, we can say, handle that exception. When a particular exception is thrown, the control of the program is transferred to the term catch. Now the third term is throw. Throw, as the term indicates, it is used to throw an exception. Also, throw is used to list the exceptions that a function throw, but throw is not going to handle the function is not going to handle those exception itself. So for example, we have a function, and within that function we have used this throw. So the keyword throw will be throwing an exception which a function, or that particular function inside which the throw is encapsulated, that function is not going to handle on its own. So till this point we have seen what actually this C++ exception handling is. So we can say, kind of abnormalities or runtime anomalies which are not syntax errors obviously, or some unforeseen errors are exceptions, and the mechanism to handle those exceptions, that whole process is known as exception handling. And exception handling is an advantage of C++ over C, because in C there is no exception handling, but C++ provides the feature of exception handling. And how this exception handling is going to take place, that is with the help of three keywords. One is try, another one is catch, and third one is throw. So try represents the block of code which is going to throw an exception. Throw is used to deliberately, or we can say throw is used to throw an exception, and the term catch represents a block of code that is executed when a particular exception is thrown. So basically catch is a kind of action which is to be taken in case of an exception. Now the general terms, program statements that you want to monitor for exceptions, or we can say those statements which are suspicious of creating an exception, are contained in the try block. If an exception, or exception occurs within the try block, it is thrown, and in order to throw an exception, the keyword throw is used, and an exception is caught, or an exception will be caught using the catch keyword, and it is processed. So basically what are the function of these three keywords is, the suspicious code goes inside the try block. If there is an exception, or if there is a runtime error which occurs within the try block, an exception is thrown, and it is thrown using the term throw. And after throwing, whenever the keyword throw is throwing an exception, this exception is handled, and we can say not handled, but we can say exception is processed, or exception is caught inside the catch block using the catch keyword. Now try block contains the code which is to be monitored. So these may have that code may have the functions which are called within a try block, may also throw an exception. So there can be, we have a function, that function is being called inside the try block, but no kind of normal or native code of the try block is not throwing the exception, but that function which is being called inside the try block may also throw an exception. So it could be the code which is native to the try block, or it could be the function which is being called inside the try block that may throw the exception. Now these exceptions which are that can be thrown by the monitored code are caught by a catch statement. But here one thing which is to be noticed is this catch statement must immediately follows the try statement in which the exception was thrown. So basically we will be having a try block, try, then opening and closing braces, and then immediately followed by the try block there must be a catch statement which is there to handle those errors or those exceptions which are thrown which are thrown by the statements present inside the try block. So a try block immediately followed by a catch block is mandatory. We cannot have any code or any kind of line of code, not even a single line of code between try and catch. So try immediately followed by catch is the thumb rule here. Now the point is, we have seen what is kind of exception handling, what are the keywords, what is the function of those keywords, but we really kind of wonder that why do we need exception handling? Is it kind of really necessary to have exception handling as a separate facility? So yes, we can say there are some advantages of exception handling. So first of them is a separation of error handling code from the normal code. That means if we are as I have told you that the code which is suspicious will be written inside the try block, and the code which is there to handle the exception will be written inside the catch block. So what I am trying to do here in the program is the code, suspicious code in one block, and the code which is kind of having its cure or having its handling procedure inside the another block which is catch. So there is a separation of error handling code from the normal code. This doesn't happen inside the kind of traditional error handling codes. If you can see what are traditional error handling codes, there is always an if else condition which is there to handle the error. So if this kind of error, then do this, else do that. So something of that sort which comes up inside the program is actually, we can say intermingled with the program, because there is no separation. If else is such a common statement which is also used inside the for the normal flow, but whenever I am talking about the specific blocks like catch block, that means I am separating the error handling code from the normal code, while in traditional error handling situations the code to handle the errors get mixed up with the normal flow, because if else is actually a kind of normal branching statement which is being used very often. So what happens if we have these error handling codes mixed up with the normal flow? This is going to make the code very little readable, we can say, and it is also difficult to maintain. By using try and catch block, the code for error handlings becomes separate from the normal flow, and the readability obviously increases and maintainability is ensured. So first advantage of exception handling is separation of error handling codes from the normal code. Coming to the next advantage, when we talk about the next advantage, it is any function or any method can handle the exceptions they choose. What does it mean? A function can throw many exceptions, but it may choose to handle only some of them. Other exceptions are just thrown but not caught, or not handled but not caught can be handled by the caller. So basically a function can throw many exceptions but may choose to handle some of them. That is perfectly possible in C++. Also in C++, a function can specify the exception that it throws using the throw keyword. There is a throw keyword also, we will be using it in our program, and the caller of this function which is using the keyword throw must handle the exception in some way. either by specifying it, kind of again, or handling it, or by catching it. So the example of this throw inside a function, we will be looking into that example in a short while. Another type of advantage which comes up with the exception handling is grouping of error types. So grouping of error types basically means in C++ we can have exceptions as basic types as well as for objects. So basically both basic data types and the user defined data types, which are objects, can be thrown as exception. So we can have a hierarchy of exception objects. We can group the exceptions within the in the name of their namespaces or classes, or we can categorize them according to the types. For example, exceptions of object types in one block of code, exceptions of simple types in another block of code, and within the simple type we can have different categories as well. So basically what I am trying to say here is we can group many error types when we are talking about the exception handling. We can have objects in a separate catch block, then we can have your primary data types in the separate catch blocks. So this essentially means that a program or a try block can have multiple catches. So basically we can say that we will have a try block, and it is not necessary to have only one catch block corresponding to one try block. There is no concept of 1:1 matching between try and catch. We can have multiple catches corresponding to one try or throw, depending upon what kind of exceptions that particular code inside the try block is capable of throwing. If the code is capable of throwing multiple exceptions, we will be handling them with the help of multiple catch blocks. So coming to, if we see the general format of a try catch block, this will be in the form of, let's say, try and then opening braces, and within the this try block of opening and closing braces we have all the code which is to be monitored, which is suspicious of throwing the exceptions. Then we can have catch blocks. If you can see on the screen, I am having multiple catch blocks here: catch type 1 argument, catch type 2 argument, and every catch block is having its own separate code or separate way of handling the exception of type 1 argument or handling the exception of type 2 argument. So I'll be explaining in the next lecture. I'll also be explaining that what is the meaning of this type 1 argument and type 2 argument, and similarly we can have n number of catch blocks which are in the form of type n argument. So this was basically the today's agenda, in which we have seen what is exception handling, why this exception handling is necessary, and we have seen just a general format and how to use this exception handling within a program. And here is a list of references which is used in the preparation of the lecture. Hope you had a fruitful learning. Thank you.